Hey, fellow mathers. Before we get into this episode, we want to share with you how you can get access to free content, professional learning that will keep your students engaged and doing the math that matters. Get ready to go to this link, mathisfigureoutable.com/challenge.
That's right. Registration is open for the free Math is Figureoutable Challenge that's starting May 15th and runs to the 17th at 7 p.m. Central. We're going to have 3 nights jam packed with learning and routines that you can take straight to your classroom.
In these challenges, we have a great time. We do some math, talk about classroom experiences, give away super cool bonuses and prizes. You won't just walk away with routines that are naturally engaging and encourage your students to think mathematically. You'll also have a chance to win over 6K worth in prizes, including a few virtual PD sessions for your school. I'll be joined by my wonderful co-host Kim and special guest Jenna Labe.
You can register at mathisfigureoutable.com/challenge for a fantastic learning experience. That's mathisfigureoutable.com/challenge. Now on to the show.
Hey, fellow mathematicians, welcome to the podcast where math is figure-outable. I'm Pam.
And I'm Kim.
And you found a place where math is not about memorizing and mimicking, waiting to be told or shown what to do, but it's about making sense of problems, noticing patterns, and reasoning using mathematical relationships. Not only are algorithms not particularly helpful in teaching mathematics, but rotely repeating steps actually keep students from being the mathematicians they can be. Are you laughing? What's so funny?
I don't know.
Because I skipped a line in the intro that I hate?
Listen, several weeks in a row, we've had a problem in the beginning. We're doing okay. All right. Hey, everyone. In our last episode, we answered a question from a follower in the Math is Figureoutable teacher Facebook group. We absolutely love hearing from listeners, and we're super excited about what you're interested in. So join the group. Tell us what you want to hear. We can't chat about everything, but we thought we'd answer some of the questions that people in the group requested.
I mean, at least we can't chat about everything at the moment, but we'll try.
I mean, we hope to do this a while, right?
We'll keep going. Yeah, bring it on. Bring on your questions. All right, so Beth Roberts, thank you for your question. Beth, you asked, or you said, division of fractions by a fraction without the keep, change, flip. What would be a good model for this? How can I help teachers? Teach mathematize your way to? I'm sorry, I'm not reading this very well. How can I help teachers teach mathematizing your way to division of a fraction by a fraction or mixed numbers for 5th grade? So let's talk about division by fractions. Division of fractions is an interesting thing. And I'm just going to mention this keep, change, flip thing is fascinating to me. A couple episodes ago, we talked about using words that aren't really well defined. And I will just note that keep, change, flip is often used for different things. So it could be used for fraction division, but I've also heard students say keep, change for addition, subtraction of integers. So that's tricky because now we're using kind of the same words to mean drastically different things. And how about if we just don't use those words at all? Because let's be clear, I'm going to call that fake math. I'm going to call that procedural math, where my job is to help students get answers to questions, not that other way of thinking about mathematizing, the real way of thinking about real math, which is how can I help my students create relationships, think more sophisticatedly, actually get their brains thinking and reasoning like mathematicians with division of fractions. So Kim, I'll never forget the day. I could picture where I was in my kitchen. I'm cooking dinner. My daughter storms in the house. I think she was 5th grade. It might have been 6th grade. But she storms in the house and I'm like, what's happening? And she is like, smoke is coming out of her ears. And she goes, Mom, divisions of fractions. Is division of fractions figure-outable? And I was like, yes. And she goes, I knew it. My teacher told me today, ours is not to reason why, just invert and multiply.
Yeah.
Now, I've heard that phrase a lot, but I've said it among teachers lately, and maybe it's not as ubiquitous as I thought it was, but ours is not to reason why, just invert and multiply is kind of a very telling statement for me.
Yeah.
Because it says don't think about math, just keep, change, flip.
Yeah.
Like just invert and multiply. You can do that and get answers, but that doesn't build your reasoning about fraction division. And so I took a deep breath and I was like, yes, fraction division is figure outable. Let's do some work. And then we
Why
did. Go ahead.
why didn't you put her in my 5th grade class?
Oh, don't even go there. So, listeners, what you might not know, Kim is rubbing salt in a wound. What you might not know is that Kim taught my number 2. She taught my number 3. And when my number
Sorry.
4, I have 4 kids. When my number 4, who probably needed her the most, was about to have her, Kim's principal. So Kim taught in the school that my kids went to. Kim's principal went and opened a new school. So a new school was opening in the district. Kim's principal was leaving. We love that principal. Hey, Jody Weimer. And Kim went with her to open the new school. And I
So
said,
sorry.
and I had a very serious conversation with Kim. And I said, no, Kim, no, I need one more year here. Like, can you please just stay at the school for one more year? And then you can go anywhere you want. But I need my kid to have you for 5th grade, please. Pretty please, 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 please. And she said, Pam, Abby will be fine. There's fine. It'll be fine. And you're laughing, Kim, because then what we had a conversation recently, right? You want to tell that? You tell that story.
I don't remember what you're talking about, but
about your own personal kid.
Well, I think I called you one day and said, I get it. Like I'm in the same boat now and I get it. And I'm really sorry I did that to you. And I'm really sorry I brought it up today.
Yeah, I think you started that conversation with, I'm so sorry.
Yeah,
and I said, for what? For what? Like, what's going on? She go, oh, now I get it. I get what happened. Yeah. I get why you were so desperate to have me stay and teach your daughter because y'all, my daughter can absolutely mathematize with the best of them, but she wants to know why. And it makes her stir crazy. It infuriates her when teachers refuse to delve into the why. And in this case, and I have to say to her every time, sweetheart, I don't think they know why. Like, they don't know why. They're doing the best they can. Come home. We'll talk about it. We'll do all the math together. All right. So we did some division of fractions, and sure enough, my daughter can divide fractions, thinking and reasoning like we're going to today. So
sorry,
Kim,
derail us.
No, that was kind of funny. So Kim, let's do a problem string.
Okay.
To develop one of the major relationships in fraction division. Okay. And today we're going to take a quotitive approach.
Okay.
What do I mean by that? So division has 2 major interpretations, 2 major ways of thinking about division. And so let's just sort of be clear on what I mean by quotitive division quickly. If I said 30 divided by 5, if I'm thinking quotitively, then I'm thinking about how many 5s are in 30. That's a way of thinking about that division. And so that you can think about, well, how many 5s do I know? And then I can sort of reason, okay, there's 6 5s in 30. So I can solve 30 divided by 5, thinking quotitively. How many of the divisors are in the dividend? Okay. So I know I just sort of told that it would be much better if we'd experienced that with whole numbers.
Right.
I'm sure we did something on that earlier with with partitive and quotitive somewhere on the podcast.
I feel like we have.
Maybe I'll search for that while you're solving one of these problems or not, or we'll just we have a wonderful podcast editor that will shoot me messages all the time. It's like, okay, you mentioned this one in the podcast. What episode is that? Because it's not always so obvious. Anyway. All right. So if we're thinking quotitively, so I'm just going to encourage you, Kim, to think quotitively about a problem like 1 divided by 1/3. 1 divided by 1/3. How would you think quotitively about that go?
So how many 1/3s are in 1? Are just 3 1/3s.
Yeah. And how do you know?
1/3, 2/3, 3/3.
Sure. Maybe. So if a kid said something like Kim just said, I would quickly draw a candy bar. I'm going to draw a rectangular candy bar. And I would say, so you're saying that if I cut that candy bar into 3 equal shares, that those are some thirds, you're saying there would be 3 of them. And that's kind of the definition of thirds, right? Like I've separated the whole, the unit into 3 equal shares, and I call each of them 1/3. And if the question is how many 1/3s are in 1 candy bar, we could clearly, and so on my paper right now, or on the board, or wherever I'm working with students, I've drawn this rectangle. I've cut it into 3 equal pieces. I've labeled each of them 1/3. And I've sort of got that on the board. Bam. So that's what we often do in a problem string, right? We ask a question everybody has access to. When they say their answer, I make that thinking visible. I, the teacher, make that thinking visible. Next question.
Yep.
Kim, what is 2 divided by 1/3?
6.
And how do you know?
There were 3/3 in one, and so you doubled your amount of candy bars, and
Uh-huh.
so now I have 6 1/3s.
Cool. So if there are 3 1/3s in one candy bar, then you're saying there's double that. There's six
Yep.
1/3s in 2 candy bars. Cool.
Yep.
So I've just now redrawn the first candy bar, but I
Yep.
didn't draw it in as much specificity. I slapped up a rectangle. I quickly cut it into thirds, and then I slapped up another rectangle next to it, quickly cut
Uh-huh.
it into thirds. I've labeled one of the thirds, one of those pieces with 1/3, and that's it. Like I haven't
Yep.
spent time doing a whole lot of, but we can clearly see that there's 3 in the one, 3 in the other. I've doubled the number, and that's 6. Cool. What if I had a problem like 4 divided by 1/3? 4 divided by 1/3. Now what?
That would be 12
Because
because we just had 6/3 for 2 candy bars, and we have
mhm.
twice as many candy bars, so we need twice as many thirds. So 12 thirds.
Cool. And so I've just sort of drawn quickly 4 candy bars. I've cut the
Hmm.
first one into thirds, and I've labeled the first one 1/3. The first third, I've labeled it 1/3, and I haven't really done much with the other ones. I've got the 4
Yep.
candy bars up there. I've got the first one chunked into 3, and I'm kind of thinking about that. I'm a little curious. Could you have thought about that? You went from the 2 candy bars and you doubled, and I love
Yeah.
that. What if you didn't have the 2 candy bars? Could you have gone from the 1 candy bar divided by one
Sure.
third?
It
Yeah,
would be 4 times as many pieces
because
because you went from 1 candy bar to 4 candy bars, and 3/3 to 4 times as much as that.
which is that
12
12.
thirds. Yeah.
Yeah, so 4 divided by 1/3 has to, since you have 4, be 4 times as many thirds,
Yeah. Yeah.
pieces. Cool. All right, so 4 divided by 1/3 is 12.
Yep.
Next question. How about 4 1/3 divided by 1/3? 4 1/3 divided by 1/3.
That would be 13.
Because
We just had 4 divided by 1/3. So how many thirds in 4? And that was 12. So now you're just asking me one more third in
so that's
4 and a third.
yeah, sorry, I didn't mean to interrupt.
That's
Cool.
okay.
So I've just slapped down 4 candy bars again,
Uh-huh.
but I've tacked on kind of a ghost candy bar, and so
Uh-huh.
I've tacked on kind of a 5th candy bar, but I've
Uh-huh.
put it in dots. It's kind of like but 1/3 of it, I've cut that into thirds, and that first third is solidly outlined. So you can see a 5th candy bar, but I've only like sort of sketched in that third. So you can clearly see 4 1/3 candy bars. And I'm asking how many thirds are in that 4 1/3. We already have the 12 from the 4 candy bars, and there's just one more. And I'm not actually going to spend a lot of time on this problem. Like, we're
Okay.
just going to, like, we had the 12, we got one more, duh, we're moving on. Cool. How about 2 2/3 divided by 1/3? 2 2/3 divided by 1/3.
That would be 8 because
Yeah.
there were 6/3 in 2 candy bars, and I have 2 more thirds. So 2 2/3 is 8 thirds.
2 more 1/3s.
Yep.
So as you were talking, I quickly slapped down 2 candy bars.
Uh-huh.
And you said because we had 2 candy bars and we had 6 1/3s in those 2 candy bars, and then you said we had 2 more thirds. So I put
Uh-huh.
another kind of ghost candy bar there, and
Yep.
but I've solidly outlined 2 of those 1/3s. And the last part of it is the last third is kind of in dots. It's kind of just sort of sitting there. So there's the 2 2/3, and then I'm kind of circling a little bit the 2 candy bars, and I'm arrowing up to where we had 2 candy bars before that. We had 6, and then I'm saying, oh, and then there's those extra 2/3,
Yep.
and so you said, so I've written by the problem 2 2/3 divided by 1/3. I've written 6 plus 2. Well, actually, I wrote 8, and then I wrote
Yep.
well 6 plus 2.
Yep.
Cool. Okay, next problem. How about 2 2/3 divided by 2/3? How many 2 1/3 are in 2 2/3?
I think it's 4
You think
2/3.
4? There's 4 2/3 in 2
Yeah,
2/3. How do you know?
because we just did 2 2/3 divided by 1/3, and there were 8 1/3s. And so now, instead of 1/3s, you're asking me about 2/3s. So the how to say this, the size of the pieces that you're asking about have doubled. And so I'm thinking about the size of the pieces have doubled, and so there's going to be less of them because the 2 2/3 didn't change. So instead of 8 1/3s, there's only going to be 4 2/3s. There's going to be half as many pieces because the size of the piece doubled.
Half as many pieces that are twice as big.
Yeah.
I wonder if we could do a little more candy bar talk. So,
Okay.
in the problem before, I'm not, yeah, well said. In the problem before, we had 2 2/3 candy bars.
Yep.
And I kind of said, if I'm giving everybody a third of a candy bar, how many people can get a third of a candy bar? How many
Mm,
1/3s can I get out of 2 2/3 candy bars?
yeah, that was 8.
You said there were eight.
Uh
Eight,
huh.
eight portions, 8 of those
Yep.
1/3s I could sort of hand out to people.
Yep.
In the next problem, I said 2 2/3 divided by 2/3. Could
Yeah.
you tell me what that would mean in the candy bar problem?
Yeah. So now each person, I have the same amount of candy bar total, but instead of people only getting a third, they're going to get 2/3. So they get twice as much. And so I'm thinking about how many people can I feed now? If I'm giving twice as much,
Per
then only
person.
the first 4 people are going to get some.
Yeah, because if you start with the total amount of candy bars and you give each person twice as much, you can only give that out to half as many people.
Right.
So that would be 4. 2 2/3 divided by 2/3 is 4. And that would be some beginning reasoning that I would want to do with students about fraction division.
Yeah.
Let's maybe parse out a few things that we did. So one, we have to be able to think about division as quotitive division, as
Yeah.
how many of the divisors are in the dividend. How many if I have this many candy bars, this much of a
Yep.
candy bar, and I want to dole out pieces of the candy bar, sections of the candy bar, how many people can I feed? So like the first problem, if I had a candy bar and I'm giving out 1/3 pieces, how many of there are there? You said there were 3. If I double the candy bars and I have 2 candy bars and I'm doling out 1/3 of the candy bar to the people, how many people could I feed? Well, I doubled the number of candy bars, but I'm still giving out the same amount. Well, then I could give that same amount to twice as many people. So we had 6 pieces.
Yeah.
So there's this relationship of if I double the dividend, if I double the total, but I keep the divisor the same, I keep the share the same, then I could give that share to twice as many people. That's a big
Wait. You said
relation.
if you double the amount they get.
Oh, no, sorry. I double the total, but I keep
Ah,
the
okay. Yeah.
portion the same. I
Yeah.
keep the
Okay.
portion, the
Yes.
amount they get the same.
Yep.
Then I could give that portion to twice as many people because I
Yes.
doubled the total.
Yep.
That relationship, ideally, we would have developed with whole numbers.
Yes.
Before, notice the way I just said that, if I double the number of candy bars, but I keep the portion the same, I can give that portion to twice as many people because I doubled the number of candy bars.
Yep.
That relationship, ideally, we would have developed with whole numbers before we hit this place where we're trying to reason about division with fractions.
Right.
Now, if you haven't, you might want to do a problem string with whole numbers into this problem string with fractions. I think that would be a helpful thing. But we still can reason, especially if I've got the candy bars up on the board. We still can reason about these chunks of candy bars with students. It's just going to be, we're thinking about more complicated numbers. So it's one of the reasons why I really encourage people to think and reason about division with whole numbers, not just do stuff, not just do an algorithm. If all we've done with division of whole numbers is stick numbers in an algorithm and then perform a bunch of steps, does McDonald's sell cheeseburgers and do dirty monkeys smell bad? Like whatever that algorithm is that you've done for division with whole numbers, if we've done that with division of whole numbers, thinking about division of fractions is going to be more difficult. We're going to have to do more building of, I can think quotitively. And not only quotitively, but this idea of if I double the dividend, keep the divisor the same, then I can double the quotient. That's a big idea that I wish kids owned, so that we could sort of just like then investigate it, make it strong with fractions. We can use that same understanding. Maybe do you want to say anything before I point out a couple other things I did?
No, it's just interesting that you're talking about this right now, because just last night, Cooper, my younger, was asked to do something with 90 divided by 5. And he was like, ugh, I don't want to think about fives. And so he thought about 180 divided by 10. So it's just it's a nice example of how he thought about twice as much in a whole number setting in order to get the answer that he needed.
Ah, very nice. I will point out that if he's going to solve 90 divided by 5 by solving the equivalent problem, 180 divided by 10, brilliant. I love your kid. That's actually the partitive meaning of division.
Yes, you're right.
Yeah, which we would want to develop. It's not what we were messing with today, but I wouldn't want to stifle Cooper when he does that. I would want to like absolutely celebrate the thinking he's doing. In the midst of this problem string, though, I'm going to keep the context alive about candy bars and divvying him out to kids, which will kind of keep him thinking quotitively here. But I'm not going to like, oh, no, we're not doing that today. Stop doing that. I'll totally support what he's doing, and I'll draw him into the context that we're using, which leads me to what a thing I was going to point out is that we did it in context, right? So context is hugely important. I think we need to have kids involved in contexts and then get naked, then decontextualize and help them think out of context. But as we decontextualize, draw back on major contexts that we've used until kids can solve contextual problems and decontextualize problems and go back. That we want the flexibility that they can go back and forth between them. That's the ideal goal. And we do that by starting with context and helping kids really reason in context, and then moving more abstractly. There was one other thing I wanted to point out that I did. Kim, every time we did one of those problems, I did not command you to draw a model, right?
Right.
Did I stop you from drawing a model?
No, actually, I sketched part of the problem string with a model, and then I just kind of stopped.
And I wonder if I had been sketching your thinking where you could see it. We're just audio recording your house and my house. If I was sketching so you could see it, you might not even have sketched those first couple ones, right? Because I would have had. And you probably sketched them because you were wondering, hey, maybe this is going to help me later on. And as you were reasoning, you're like, I don't need that to help me. Right. But I would have been. So we're just going to suggest that with problem strings, often it is that we draw out students' thinking and we make it visible. Right. We choose the model, we make it visible, and we help put something on the board that we can point at, that we can compare, that we can have discussions about, because it's visible. And that's a huge part of what we're recommending as we're developing all the things. So, Kim, this was not enough. We have not done enough work with fraction division yet. How about if we are you up to doing a couple more podcasts where we'll dive deeper into fraction division?
Sure. Yeah.
All right. We'll do that in our next episode. Listeners, you are not going to want to miss our next episode or 2 or 3. I don't know how many we'll do to dive into really developing fraction division. Y'all, thanks for tuning in and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com. Let's keep spreading the word that math is figureoutable. Thank you for listening and making math more figureoutable.
To learn even more, make sure you register for our free challenge at mathisfigureoutable.com/challenge. You are not going to want to miss the evenings of May 15th through 17th, starting at 7 p.m. Central.
Math teaching, go register now. That's mathisforgettable.com/challenge. Join us to make math more and more figure outable. And if you can't join live, register and we'll send you access to the recordings. We'll see you there.